In this video, we're going to look at the keto-enol equilibrium. Now, what does that mean? This is a ketone. This is called a molecule called an enol, which is a double bond with an OH on it. Which for short, we call this keto. We call that enol. The equilibrium between them is the keto-enol equilibrium. Now, this equilibrium occurs in solution all the time, but its equilibrium constant is very small, 10 to the minus 6. So only one molecule in a million is in this form. But the equilibrium is going back and forth rapidly. Now, how does that work? Well, it's catalyzed by either hydroxide or protons. And so there's two different mechanisms depending upon the pH of the solution. So let's first go through the mechanisms for a basic solution. So let's say the pH was just a little bit negative. We just want the pH was just a little bit above 7. We want just a little bit of hydroxide present. Now, to do this, I need to draw in a hydrogen atom. So here I'm going to add a hydrogen atom to the methyl so I can use it in my mechanism. So what's going to happen? Well, what's going to happen is we're going to form an enolate. This hydroxide is going to come over, pluck off that proton. The bonds to the hydrogen will form a double bond, and the carbonyl oxygens will go out onto the oxygen. This will give us an enol. And I can draw that out over here, come down, erase the hydrogen, put in the double bond, take that to a single bond, and put on the minus charge. So now we have an enolate. And of course, this enolate is not going to be very much concentration here because we're assuming that the pH is only slightly above 7. There's just catalytic hydroxide around. But what's going to happen, of course, is that this is simply can go back. It could go back to where it came from by reacting with a mole of water, but that'd be kind of boring. But in some cases, 1 in a million, what will happen is it will take that water molecule and it will pluck the hydrogen off the water molecule and go to the enol. So that's the mechanism for the base catalyzed equilibrium. So let's go through and do the exact same thing for an acid catalyzed position. Let me erase all this. It's history. It's gone. And I'm going to erase the hydroxide. And let's say instead of the pH slightly above 7, let's say it's slightly below 7. So we have an excess of protons. Now what's going to happen? Well, now the proton is going to look for a site of electrons. And what it sees over there is the lone pair on the oxygen. So we're going to protonate the oxygen. This will give us our first intermediate, which is simply the protonated ketone. Draw this out. It has a positive charge. Okay, and now we're all set to do some magic, because what happens is I should draw an arrow in there. Here's the arrow. Okay, so what's going to happen is our double bond is going to shift. The way it's going to shift is we're going to pluck off that hydrogen. So we need a water molecule to act as a base. So let me draw that in. So here's our water molecule, and the water molecule is going to come over here and pluck off that hydrogen. It's going to form a double bond, and then this go out to the guys, and that is formed our enol. So either way, acid catalyzed, base catalyzed, this equilibrium will take place, but only at a concentration of 10 to the minus 6, not much.